Hey. Start soon here, kiddos. Share my screen. Just want to make sure that you know where the actual lab pages are. I don't need you to tell me who's doing it. Let's hope that it didn't break Zoom. There we go. We need to look. I can't see it right now. Volcano Lab. I had it open here. So it's in the same worksheet packet we've been working on. I apparently deleted the instruction page, which I should actually open up. But the 2 pages that you need to work on are the 5th and 6th page in the packet. They've got these questions. Oh no, that one. Maybe there were questions on page 4. Whoops. There were a couple of questions on page 4, but I told on the assignment, I said, don't post a picture of it, whatever. We can not post a picture of it. That's fine. But what we're doing today is going to go through these instructions here. We're going to make models of 3 types of lava. And I am going to make 4 of them because I will have a mutiny if one of my children doesn't get to make this. So there's going to be a 4th one that really doesn't matter. I might just make 2 basaltic lavas or something. I don't know. But that's why I'm going to have 4 when we really only need 3. So that's what I hope to show you today is the lava types here. We've got basaltic. It has the least amount of salt, which represents an element called silica, or like quartz is silica, essentially glass, sand, that kind of stuff. We've got andesitic, and we've got rhyolitic, which has the most silica, and we're going to see some differences in the properties of lava or magma with corn syrup and salt. So it's going to show us what are properties, even though it's obviously not lava. With that, let's put those here. So our basaltic has 1 teaspoon, 2 teaspoons for andesitic, and 3 teaspoons for rhyolitic. So if I go back here and stop sharing, at this point I can use my phone. Let's see if there's any, nope, no more that need to get let in. Let's mute this, and then I'll go get my phone. Okay. Oops. Bring up. Are they upside down now? They are. Okay.
I saw Miss Kathy on that.
You saw Miss Kathy? Oh my goodness. Okay. So what we need is corn syrup, and really you can use food coloring. Make it look a little bit more lava-y, but it's not really necessary. So if I put some in here and we stir it up, it's obviously going to be red corn syrup now.
Dad, can I help you stir?
Yes, you can, because I got to hold the phone. Please stir it, Eli.
Yeah. It's really yellow.
Okay, so we've got our lava now of sorts, and really the next step was saying, I think they said measure out 5 milliliters of syrup, which is pretty hard to do with out a graduated cylinder. But really, you just take any of these cups, Easton, I need the cup, and you're gonna fill it, I don't know, like a centimeter or so high. As long as you've got about the same amount in every container, it really doesn't matter. So,
You look like Jello.
okay, I'm gonna attempt to get my
Like
here. So now I need our cups, kiddos, and I just gonna put some in here. Okay, so after this, the next part that we're going to add is salt to it, which is It's going to represent how much silica we have in the lava.
So,
The reason why we care about this in general, and the reason why we care about this at all is the amount of silica that goes in magma will trap different amounts of gas. So that makes some lavas a little bit more explosive. The eruptions will be more violent.
What's violent?
It means there'll be bigger eruptions, and it'll throw stuff into the air, and it will make different kinds of rocks, and it'll make different kinds of volcanoes. So that's why we're looking at the types of lava here, is to get an idea, get a real life example of why there are different kinds of volcanoes and how those form, like why there's a composite volcano, why there's a cinder cone, why there's, what's the other one, a shield volcano. So they all three different kinds of volcanoes form because of the different magma that is underneath of them, how much they trap gases. So let's see, is it upside down? Nope, we're good. So now we have our lava here. Now I need some salt. Okay, you just table salt is fine. I'm probably using way too much, but I need my kids to scoop, so they need a little bit. Okay, and then I kind of converted it from teaspoons to just doing tablespoons. Eli, do 3. You're gonna be, nope, 3 full ones, dude. 3 full scoops. You're gonna be the, what? This, rhyolitic, I think, is the one with the most. I'll double check that here soon. 3 of them, Eli. That one's not full. Maybe Daddy should get some more salt in there. Okay, that's full enough.
Now this one.
Okay, that's good. Dump it in. So what I need you to do now, Eli, is
What?
I'm going to get you a spoon or something, and I want you to mix it in. Easton, I want you to get 1 scoop. You're going to be the basaltic lava.
What lava am I?
Yep, just stir yours up, Eli, so it's all nice and mixed.
What's mine?
What?
What's mine, Dad?
Yours is the rhyolitic. Let me confirm that.
Bill.
Yes. Yours is the rhyolitic, Eli.
How can we get? Did you get 1 full scoop?
Okay, you got 1 full scoop. Looks good enough. Wasn't really sure if you got a full scoop or not, but it's close. You need 2 scoops, 2 full scoops, Emma. And I need to get you a spoon, Easton, so you can stir. No, Emma, you need me to help you hold that up?
Yes.
Okay. Okay, that's good enough. Dump that one in.
Yucky.
Hey, we're not, I don't know, doing any kind of fancy chemical reactions or anything, so being precise isn't really super necessary today. And Bug, come on, Lena. Lena, Bug. There you go. We'll dump yours in, and you can mix, and you're gonna be my extra one. Okay.
Wait, but the extra one?
Yes, because I only really need 3.
Yeah.
So, Easton, how many scoops did you have in? 1. Okay, so you're the basaltic lava. Eli, how many scoops did you have in?
3.
3, so you're the rhyolitic. And Emma, how many did you put in?
2.
2, so you're the andesitic lava. You're the in-between kind. Okay. Now, I need your spoons, because we don't need them anymore once they're stirred. Hey, Emma. There you go. Okay, Elena, give me your spoon. Thank you. Wait. Now we each need a straw. So this is the part where we're going to show how much gas our lava traps. Okay. So what we need to do is we need to blow bubbles into it, kiddos.
Blow bubbles?
Okay, stick your straw into it all the way in, Easton.
Like all the way to
And
the
blow
bottom?
bubbles. So this is the basaltic lava.
All the way to the bottom?
Yep, all the way to the bottom. Let me see if I can help you out here, dude. Maybe. It's going to be really hard for me to video and videotape at the same time. Let's see. Got it. So really what we should be looking for right now is how well these trap the bubbles comparatively. So we've seen the basaltic. You probably don't know how well that traps gas yet because we haven't seen any of the others. Let's go to the next one up, which is Emma with 2 scoops of silica. Okay, you blowing bubbles, Emma?
Yeah, but
Okay.
they
Let me help you out too. Okay.
Yes, I made it to water. I made
So it takes a little bit more pressure for me to blow bubbles or air this one.
I got
So let's take a look at our third one here with 3 scoops, which was rhyolitic lava. Can you move your head here quick, Eli? Oh dear Lord, I can't even blow a bubble in it. How did you do that?
I can.
Okay, there we got one. So, yeah, I know you got bubbles. Okay, I had to blow pretty hard to get a bubble to come up. So, what we should be noticing here is when it's just corn syrup, like the basaltic lava, it's pretty easy to blow bubbles in there. It doesn't trap the gases very well. When we start working our way up to the 2 scoops, which is the andesitic, a little bit harder. And then when I get to the 3 scoops, which is the rhyolitic, you need to, like, you blow bubbles, you blow air into the lava a lot before it explodes or erupts into the surface. So you have to put a pretty good amount of force behind it. And then I actually just got splashed kind of in the eye with corn syrup. So there's a little bit of explosive eruption there when you trap gases. So that's the whole point here of this lab, is if I take a look at some of the questions later on, we made our lavas, we recorded our observations when we blew bubbles in them.
Gross.
And what the next couple pages are is compare the viscosity. I didn't really show that. So viscosity for us means how thick the lavas are, how fast they flow. So if I just move this back and forth for the viscosity, what we notice is it's syrupy, so it's not like flowing like water would, but it's not much different than the viscosity of corn syrup. So if I go to, Emma, I need your cup, please. Okay, can you take your straw out? If we go to the andesitic, which had 2 scoops, it's a little bit thicker. It's moving a little bit slower. It's not quite as goopy as the last one. So that silica, that salt, has made it a tad thicker or tad more viscous is really what that's telling us. And then this is my straw. Can I use yours, Eli?
Yeah.
Okay, and then if I move this one, it's even slower. So let's put those side by side if I can. Eli, can you help me? I want you to hold it up. Eli, this one. This is the basaltic that Eli is holding here. And I want you to tip it towards the camera, Eli, like this at the same time. So let's hold it flat. On your marks, get set, pick it up and flip it. Okay, when I say go. Do you understand what you're doing?
Yeah.
Okay, on your marks, get set, go. Flip it. Flip it more. You gotta flip it faster, dude. Okay, let's put it back down. I want you to pick it up and flip it. Okay, perfect. That way. Now let's hold it this way. Okay.
Do it again.
Put your straw down. Yes, dude. With that one, dude. So Eli's got the basaltic. I've got the rhyolitic. Okay, flip, 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 flip. all the way, like you're pouring it out, dude. Okay, you can definitely see the side-by-side comparison there of the viscosity. I've got mine even at a more extreme angle, like it's tipped further than Eli, but it took longer for my lava to get there. So that's what the viscosity questions are about. We've got our basaltic, which has the least amount of silica, which was the one Eli was just holding. Yes, you can. And we've got the andesitic, which was my daughter Emma's, the one with 2 scoops. I didn't do the side-by-side comparison of that one, but you kind of gotta, at this point, understand that andesitic is kind of a combo of all the types, the 2 types of lava. It's in between. So then you rate the silica content, which is amount of salt in each type of lava. So I would be expecting one of these 3 names. Oops, I guess I should point it out. I would be expecting one of the 3 names of basaltic, andesitic, or rhyolitic. How does it increase? Kiddos. You can blow bubbles, but please be quiet, okay?
It's hard to stay quiet when they burst.
Well, the bubbles are fine. You yelling and screaming and hollering, not so much.
Guys,
No. Okay, lowest silica content, intermediate silica. Okay, I was here. How does an increase in silica, meaning salt, change the viscosity of lava? Eli. What we mean there is, you know, if I increase the silica, this happens to the viscosity. That's essentially what you would be saying there. And then identify the lowest to highest viscosity, which is kind of the same question as the one on the top, except it's kind of opposite. They gave you the lava there. Here, they're giving you the viscosity. Okay. And then this is where the gases come in here on the bottom part. So we have which type of lava do you think allows gases to escape the easiest and why? So you would want to be talking about viscosity. You want to be talking about what you saw in the lavas here with how easy it was to blow into the lavas and get a bubble to form. Which type of lava do you think it makes it most difficult or they escape the hardest? And then this is where we're kind of linking the lava, the magma, to the fact that the volcano eruption is explosive or kind of mild. So explosive ones are, do they go over it on this page at all? I think they just expect you to know the volcanoes. Okay, yes. So let's talk about the volcanoes. You can watch my note video too for more information on this stuff. But we've got explosive volcanoes are called cinder cones. They form a lot of lava rocks, I would say, like ones with holes in them, like gas bubbles. They can form, what else? What's that one? Obsidian. They can form like ash and pumice, which is another kind of volcanic rock that comes out from explosive eruptions. So they end up just pretty much being a pile of rock chunks, ash, kind of like a giant sand pile with a crater in the middle. They don't have much structure. They can't get super, super tall like a composite, an in-betweener can, the ones that we usually think of as a volcano. So that brings us to a composite, which has some explosive eruptions and some mild eruptions, which is because it's kind of in between. It has a mixture of both lavas. On our sheet here, the mixture of both, the mixture of both lavas was the andesitic, the one with 2 teaspoons. What, Elena? Just a minute, Elena. Okay, and then the least explosive volcanoes, this is the one where the magma just kind of, this is the one, I don't know why you decided to change your shirt right now, child. You also have it on backwards. Weirdo. Okay, The least explosive is where the magma just kind of bubbles out of the volcano and you don't have like any explosions. You don't have massive eruptions. And this is like Hawaii's volcanoes, which are called shield volcanoes. Elena. I know. It's like the shield volcanoes in Hawaii where they're just kind of erupting all the time and there's lava spewing out of it. And I don't know. There's super hard to do this with a bunch of kids around. I lose my focus all the time. They have a very broad shape, so it's not like a mountain. It's a shield. It's got a little tiny bump in the middle, but it's pretty flat otherwise. Whereas when you think of a composite volcano, you think of a big classic mountain that's a triangle, very tall. Think Mount St. Helens or Pompeii or any of those kinds of things. And cinder cones are weird looking. I have the pictures of those up in my notes, which, to be perfectly honest, might help you out with, where did my mouse go? There, I'll just use that, I guess. Where is that? Okay. This page, which is kind of sideways, has the 3 types of lava. You want to rank your silica content from high to low, or medium is an option too. Same thing with lava viscosity, how thick or how well the lava flows. We want to remember that viscosity, the lower it is, the more like water it is, meaning it flows fast, the bubbles don't get trapped, that kind of thing. And high means super thick, slow moving, traps gases pretty well. Where the gas content is meaning, does it trap bubbles or does it not trap bubbles? How easily does it do that is what the gas content is talking about. And then what kind of eruption does that mean? If it traps gases, does that mean it's explosive eruption? Does it mean it's a weak eruption, or is it in between? That kind of thing. And then the last 2 are maybe where you would get from my notes video. It would give you the names. Remember our name options for volcano type. Just a minute. Is shield volcano, which are weak, gentle eruptions. We have the in-betweeners, which are the composite volcanoes. They can have some explosive and some fairly mild. And the always explosive is cinder cones, which is just kind of a pile of volcanic rocks and ash and that kind of stuff. And then you can either Google those and do a little sketch. You can watch my video and do a sketch because it's part of our notes too. Either way. Okay. I think I've done what I need to do, and now I guess I can pop back in. I have honestly not checked to see if there's any questions or anything. Whoops, I have a lot of people who are trying to get in. Sorry. Needs to be let into the meeting. Didn't get let in. Whoops. Are there any questions? Whether you do it in chat or unmute, I don't care at this point. Just wondering if we make sense. If you had any questions about or need to see anything again, like you want me to, whatever. Grayson's good. Lily's doing something with dough or clay or slime. I'm not sure what. Dad, Olivia's good.
This could be good slime.
Really?
Yeah.
I think it would be incredibly sticky slime, and that makes it absolutely nightmarish in my opinion.
Well, it could be good sticky slime.
Otherwise, I can stop this recording because that's all we need.
Do that.